Good morning to everyone. Myself, P. Vanita, working as an astronomy professor in the Department of Electrical and Electronics Engineering. Today, I am going to present the topic maximum power point tracking, commonly known as MPPT. MPPT is an essential technique used in solar photovoltaic systems to extract the maximum possible power from solar panels. Since solar irradiance and temperature continuously change throughout the day, the output power of a PV panel also varies. MPPT helps the system operate at its optimum point, thereby improving efficiency and energy generation. In this presentation, we will discuss the need for MPPT, its working principle, various techniques, advantages, and applications. MPPT stands for Maximum Power Point Tracking. It is a control technique used in solar photovoltaic systems to maximize the power extracted from solar panels. Every PV panel has a specific operating point where it can deliver maximum power under given environmental conditions. This point is known as the maximum power point or MPP. Without MPPT, the PV panels may not operate at this optimum point, leading to energy losses. Therefore, MPPT controllers continuously track their maximum power point and ensure that the solar panel delivers the highest possible output power. This significantly improves the overall efficiency and performance of solar energy systems. MPPT is necessary because the operating conditions of solar panels constantly change. The amount of sunlight received by the panel, known as solar irradiance, varies throughout the day due to weather conditions, cloud cover, and seasonal changes. Similarly, temperature affects the output voltage of the solar panel. As the temperature increases, the voltage generally decreases, causing changes in power output. Since the maximum power point shifts continuously with irradiance and temperature, a fixed operating point cannot provide maximum power at all times. MPPT overcomes this problem by continuously adjusting the operating point of the PV system and ensuring maximum energy harvesting under all environmental conditions. To understand MPPT, it is important to study the characteristics of a solar PV panels. In the first characteristics is the current voltage or IV curve, which shows the relationship between output current and voltage. As voltage increases, the current remains almost constant initially and then drops rapidly. The second characteristic is the power voltage or PV curve. This curve shows how power varies with voltage. At one particular point on the curve, the power reaches its maximum value. This point is called the maximum power point or MPP. The main objective of MPPT is to continuously identify and operate at this point so that the maximum power can be extracted from the solar panel. The working principle of MPPT involves continuous monitoring and control of the solar panel output. First, the MPPT controller measures the voltage and current produced by the PV panel. Using these values, it calculates the output power. Next, the controller compares the current power with the previous power value. Based on this comparison, it determines whether the operating point is moving moving toward or away from the maximum power point. The controller then adjusts the operating voltage using a DC to DC converter. The controller then adjusts the operating voltage using a DC to DC converter. This process is repeated continuously until the panel operates at or near the maximum power point, ensuring maximum energy extraction. This slide shows the basic block diagram of an MPPT system. The PV array generates electrical power from sunlight. Voltage and current sensors continuously monitor the output of the PV array. The measured values are sent to the MPPT algorithm, which calculates the optimum operating point. Based on the algorithm's decision, control signals are sent to the power converter. The power converters adjust the voltage and current conditions of the PV panels. Finally, the optimized power is supplied to the load or battery storage system. Thus, all these components work together to maximize power transfer from the solar panel to the load. There are several techniques available for implementing MPPT. The most common method is the perturb and observe or P and O algorithm. It is simple and widely used in commercial systems. Another popular technique is incremental conductance, which provides better accuracy under rapidly changing weather conditions. The constant voltage method is a simpler approach that approximates the maximum power point based on the fixed voltage ratio. Advanced methods such as fuzzy logic control and artificial neural networks use intelligent control techniques to improve tracking speed and accuracy. The choice of MPPT method depends on factors such as cost, complexity, accuracy, and response speed. The P&O method is the most widely used MPPT algorithm due to its simplicity and a low implementation cost. In this method, the controller slightly changes or perturbs the operating voltage of the solar panels and observes the resulting change in power. If the power increases, the controller continues adjusting in the same direction. If the power decreases, it reverses the direction of the adjustment. This process is repeated continuously, allowing the operating point to remain close to the maximum power point. Although simple and effective, the P and O method may cause small oscillations around the maximum power point, especially under rapidly changing environmental conditions. MPPT offers several significant advantages. It increases the efficiency of solar PV systems by ensuring maximum power extraction. This results in higher energy yield and better utilization of available sunlight. MPPT also improves battery charging performance and reduces energy losses. As a result, the overall reliability and effectiveness of the renewable energy system are enhanced. Because of these benefits, MPPT is widely used in solar power plants, residential rooftop installation, solar water pumping systems, electric vehicles, and standalone renewable energy systems operating in remote areas. Today, almost every modern solar energy system incorporates MPPT technology. Thank you for your attention. To summarize, maximum power point tracking is a vital technology in photovoltaic system that enables solar panels to operate at their maximum power point despite changing environmental conditions. By continuously tracking the optimum operating point, MPPT improves efficiency, increases energy generation, and enhances the performance of solar power systems. As renewable energy becomes increasingly important, MPPT will continue to play a key role in maximum solar energy utilization. Thank you.